Welcome to another JS drop from ThisDot. In this drop, Jan Kaiser, software engineer at ThisDot Labs, explains the basics of Angular signals in Angular 16 and shows you how to use them in an application. Like and subscribe for more JavaScript content. Let's get started.
Hi, I'm Jan, and I'm a senior software engineer at ThisDot. And I love Angular, and I love the new goodies that the Angular team released with version 16. And I would love to tell you about the amazing new reactive primitives they released. So we have settable signals, we have computed signals, and we have effects. And a settable signal, I'm sharing here an actual type definition from the Angular source code. A settable signal is a container that holds a value that can change over time. So you can imagine it similar to a behavior subject. It has an initial value, consumers can subscribe to it, and you can call a method to update that value, and the consumers will be notified about that change. But the difference between a signal and a behavior subject is that you don't have to manually subscribe and unsubscribe. And you can simply call the signal and you will get a new value every time it changes. And you can even call a signal inside a template. So basically, a signal also replaces the async pipe. And to actually change the value of the signal, we have three convenient methods, as you can see here in the type definition. We have a set method, which you can use to just basically override the signal's value with a new one, similar to what you do with the set value on a form control, for example. And then we have an update method where you can use an existing value to return a new modified value. I can show an example here. For example, we defined a signal with a count. Let's say the initial count will be 1, and then we can set a double count like this. So we call count update, and the parameter is the initial count, and we return a count plus 1. So that will actually not be double count, but set increment count would be a better name. But yeah, you get the gist. And then we have a mutate method, and that allows us to actually mutate or change the value directly without needing to return it. And when you are using RxJS observables, often you have several observables that you need to combine using an operator such as combine latest. And for a similar use case with signals, we can use the computed primitive to combine multiple signals, perform an operation on the signals, and whenever actually one of the signals changes, we can perform an operation, return the result in a new signal. And we will have a look at a real-world example shortly. But for now, let's have a look at the last primitive. And the last primitive is an effect. An effect is similar to a signal, but it does not actually return a signal. It just fires whenever a signal that is called inside it changes. So it can be handy to update the document object model or like a local storage, but it can also trigger the famous or infamous expression changed after it has been checked error if you try to use it to propagate state. So I would advise to use this scarcely or maybe not at all. Like in the few projects I got to actually use signals, I haven't used an effect, but it can come handy in some cases, definitely. Now, I know this all might sound a bit complicated, but I promise you Angular signals are very intuitive once you try to actually use them. And in my opinion, they are even much more intuitive than RxJS. And I've already caught myself working on an Angular 15 project and wishing to be able to upgrade and use signals instead of the complicated codependent logic of subscriptions and observables. But that being said, RxJS still has its use even after signals are production ready. For some cases like HTTP calls, async operations, it still makes sense to use RxJS. Yeah. So now let's try to actually use them to get a feeling how they work. And I have prepared a project that has a service, a component, and uses RxJS to communicate some state. And we will rewrite it together to use signals instead. So just to see what's going on, what's the UI. So I just have a grid. I can define a number of columns, number of rows. It should change, and I can click on a coordinate in the grid, and it should highlight this given square. And again, I can change it. Now you can see the highlighted square is out of my grid. Now it's back in, so it maintains the state. And we can have a look at the grid service here. We have two behavior subjects. One is the state, which holds the coordinates for the highlighted point. One is the grid, which holds the width and height of this grid with initial 10 by 10 dimensions. And then we have two public methods to set the highlighted point and to set the grid size. And we have a grid component, and this grid component has a subscription to the grid size or to the grid behavior subject and to the state behavior subject. Basically, we subscribe to the state with latest values from the grid size, and we do some mapping to return the tiles with the property if it has a highlighted point or not. We can have a look at a template as well. We use some async pipes to set some styles, a CS variable here, and here we have the inputs to set the grid width and height, and here we have the list of tiles, which is just a div with an ng4 and the click method and an ng class to set this beautiful green color for the highlighted tile. All right, so this is what we have. We have behavior subjects. So let's change them to settable signals, because as we explained, this is basically roughly an equivalent. So let's say this is a signal. I can just import it from Angular core and just basically replace these two. Signal. First, now I'm going to get a few errors because I'm calling next on a signal now, which is of course not possible. So let's try to change this as well. We can remove this next. We can also remove these dollar signs, so it will be apparent on first sight that this is not an observable. And then this state, and then we can set value. We can set the value on the grid as well. I'm still going to get errors now because I need to change the component as well. And I don't need these. Observables anymore, and instead I can use the computed. So I can say that my grid styles will be a signal, or will be a signal that will be computed from two signals. So computed, again, import from Angular core. And let's move logic here. We don't need pipe anymore. Okay, and we can now say my highlighted point. Highlighted point. Get the highlighted point from the signal I defined on the service. So this dot grid service, which is now undefined because I am okay. So I'm getting the highlighted point from the state. Notice that I need to call it because you need to call the signal to get its value, and I can do the same for its size, and I can also spread like this with height. And again, this.grid service, and I will call the grid signal. And now I can return this array directly. And let's get rid of this map operator that's left over from our RxJS implementation. And I can say just turn. And I'll need to change this a little bit. Yeah, I don't need this parameter from the map as well. That's also remnant from the RxJS implementation. So let's see what's the problem here. Does not exist. Yeah, because I have a typo, of course. And that has no errors anymore. That's amazing. Okay. And now we will have a look at the template, because that should give us some errors. Let's see how this compiles. Shouldn't compile, of course. We have this async pipe, but we can basically just say this is a signal. So okay, size.width. And here we also have an observable and an async pipe. So let's get rid of that one as well. Grid size height. And here we have an observable as well. Again, away with it. And same here. Don't forget to call it. You see, this code is getting a bit more readable, I would say, a bit simpler. Getting rid of, again, not forget to call the signal. And I think now we should compile. Let's see. Okay, this is compiling for a long time. That's suspicious. Let's see. Now it complains about grid size not existing, of course, because we didn't define it. So this dot grid size, this dot service dot grid. Okay, that seems to compile. That seems to compile. That seems to work. What if we change the size? That seems to work as well. Okay, so we have successfully rewritten this to use signals. You can see that all reacts immediately. So we saw one benefit of signals, and that is that we can write less code. We have less. We don't have to use a lot of RxJS operators to filter, map, combine latest, and so on. We just create a signal, settable signal, with an initial value. Whenever we want to change it, we call the set method, or we can call the update method or the mutate method. And then we call it whenever we want to get the value, and we always get the recent value. Magic. And yeah, the second benefit of signals is that they give you granular reactivity. And it looks like in the future we may not even need Angular zone, because signals are independent of the zone. They just work whenever, wherever. So this is pretty cool. And maybe we can also improve the grid even more, because as I mentioned, we have this update method. And so maybe we don't have to call this update grid with the existing values of the inputs. All right, so we can improve it even further, because as you remember, we have the update method on a settable signal. So we don't have to pass a height input value here. We don't have to pass a width input value here, because that already exists in our state, in our signal. So we can add a new methods instead. And let's say I want to update just the width here. Just pass this new value. And I want to update the height here with the height value. Now, of course, it won't compile. You have to go to the grid component and actually create these methods. So we'll reuse this one and say update width. And we will call a method here. Oh, sorry. That I will just comment this out for now and create update height methods. Empty. Now we compile, but of course this won't work anymore. But we will fix that momentarily. So first we will want to go to our grid service and change this. We won't need this set grid size anymore, and instead we will create a update width method. Okay. Call it set grid width, better name. Pass in the width as a number. And now we get our bit signal here, and we update the value. And we can just pass the existing value as a parameter, and return and set the new value here. So the bit width equals width that we passed in. That should work, and it's, yeah, because we actually want to mutate it. because I'm not returning. And I could also, let's try this. If I comment this out, this grid update pass in the width before. Oh, sorry. Pass in the grid. You would return. You would have to width equal width. Return grid. It should work in the same way, but this is probably a bit more elegant for our use case. So let's go with the mutate method. Let's do the same for the set grid height. Height number. And this, you mutate the grid in the same manner. Mutate, pass in the parameter, and say grid dot height equals height. We could even abstract this into one method and pass in the property or whatnot, but I think this is good enough. This is fine. So now we could try to call it this.grid service. And why can't we parse int, because we got a string from the input with. Should be to do the same for set grid height. Yeah, parse int height, and of course I'm missing a character. And now it compiles again, and let's see what happens. It seems to work. Yeah, works. So now we have used the mutate method as well as the set method on the settable signal. We have used a computed signal to actually calculate some logic around our points and return a new signal here. We can remove the import from RxJS because we don't need that anymore. And we have replaced a lot of async pipes here with calls to a signal. And this should automatically know whenever this signal changed, it should know to re-render. And it's not dependent on Angular Zone, as I said, and it's amazing. And I must say I'm in love with Angular signals. And I guess that concludes our JS drop, and I hope you learned something about signals and that you'll start to love them like I do.